and we are in the intelligence neighborhood in the Sounds and Models demo, and I'm joined here by Yufeng. Yufeng, tell us a little bit about what you do and this awesome demo that you've created.
Here we have station 1, gathering data, and we have this kind of instrument, if you will, but it's actually 5 instruments. And so each string represents a different instrument, and we can pluck our string to make different sounds. And what we're going to do is use this as our kind of data source. The sounds are going to then go into data flow and get converted into spectrograms. They're going to get moved into the frequency space. And those images can then be used to train our model. The hope is that these images will be distinct enough to be able to
represent each.
Exactly, that we can tell them apart, that we can distinguish between instrument 1, 2, 3, 4, and 5.
Cool. Okay, so we've got our training data. Now it's time to start training the model.
So with AutoML, we can train models using the data that we had, but then we don't have to do any extra work. So you can see here that the data is coming in, and you can see those are some of the spectrograms. Those are the real data that attendees have generated over the course of today.
So they're the images of the sound waves.
That's right. These are the spectrograms. And then when you train a model, it just does the training. There's not much kind of work you have to do. And when it finishes training, you can have some evaluation data that shows you the metrics around how well the model trained and how it did.
Right, so if you're new to ML, that's a great space to get started, AutoML.
That's right, it's an easy tool to get going with. And if you have some data you want to throw at AutoML Vision, it'll take care of it for you. And you can go do something else with your time. So we have this board here where you can move these kind of sliders around to different positions. And they map to different values on the screen, which change the values of hyperparameters of the actual models. Things like kernel width and height, the layer size, the number of strides, as well as the kind of number of layers you have. And that actually will change the amount of code on the screen. Once we're happy with a set of settings that we have, we can go ahead and push the button here and start a training job. And doing that, it'll assign us a name, something fun like Spinto Cap, and shoot that off to Kubeflow, where we have a pipeline to do training, and when it finishes training, it will deploy it on the Cloud AI Platform prediction service.
Awesome. So time to move to stage 3 of training our model.
Speaking of prediction.
All right, we're at the final stage now, and that's to predict the notes.
Yes, and so we're going to try to pull up the model that we've been training, Spinto Cap. It's there for us, so you can turn the crank as a selector, and then press the red button to select it.
Select.
So this is kind of like a customizable music box, and we can choose which notes to play on which instrument.
More xylophone.
You can hit the button again. So in this countdown, then we'll be able to turn this crank now. And so these are the notes that we set up. We're going to send those notes off to the Cloud AI Platform prediction service. Now, how did we do, right? Was our model any good? Because we chose those parameters kind of randomly. And so it might be good, it might not be so good. We'll see, right? It got some of them. It seemed like it might have actually missed a bunch. It did. And so, this is part of the machine learning workflow. This particular case, a pretty abysmal outcome.
Yeah, but that's all right, because that's all part of machine learning, right? It's all part of the process. So I think this is a perfect demonstration to show that. So Yufeng, thank you so much for this demonstration. I think it was very clear in kind of the 3 stages of what to expect when training machine learning models. So thank you so much.
My pleasure. Thanks so much, Natalie.
And back to you.